Anytime you're doing an experiment, always make sure that you have safety gear in your pocket. I have safety glasses, but because I wear glasses, I'm okay for almost all of these. But do make sure that you wear safety glasses in case you don't have glasses that you wear. We're going to talk about Ivory Soap. Ivory Soap is sort of a unique soap, and today we're going to do a demonstration of how it works in terms of some scientific principles. One is that it has to do with density, and I think the history of Ivory Soap is pretty unique, so I'm going to give you just a short take on it. Ivory Soap was developed in the 1800s, late 1800s, and what happened was the gentleman who was stirring the big vat of all the ingredients to make the Ivory Soap accidentally left the stir mechanism on while he went to supper one night. When he came back, he noticed that the consistency of the Ivory Soap was much different than it had been in the previous batches that he's made. Afraid he would lose his job, he said, let's go ahead and run it and try it and see what it does. So what happened when they sent it out was that the customers were thrilled because it had some very unique characteristics that it had not had before. One being that all of that extra stirring had added air bubbles into the Ivory Soap. And I don't know whether you've ever used Ivory Soap at home or not, but it has the unique capacity to float in your bathtub or in your sink. Kids usually like that. So it's sort of interesting that it does that. Now what happened is all those air pockets within the new product of Ivory Soap caused buoyancy in the water, and as a result the soap floats. So with that in mind, let's talk about what happens. When you're talking about density of products and when you add heat, or sometimes when you add cold, and we'll look at some other experiments that do cold as well, but when you add heat to things, very often it changes the molecular structure of products because of the density that's involved in the product. So we're going to take Ivory Soap, we're just going to put it on a plain old plate and stick it in a plain old microwave. We're going to turn it on for about 30 seconds and see what happens. Now, density is one of those things that has to do with lots and lots and lots of scientific principles. And we'll talk about density throughout the demonstrations that we're looking at. But as a result of what we're going to see today, I just want you to understand that those air pockets, when their heat is added, are going to cause expansion. And most of the time, heat is going to cause expansion, and cold is going to cause things to reduce. And we'll look at some other experiments that do exactly that. So we're going to see what happens when Ivory Soap is added with heat, and those air pockets are affected by the heat, and as a result, we'll see what happens to the Ivory Soap. So, here is Ivory Soap with a few seconds in the microwave. Pretty cool.